Well, hello everyone, and welcome to this video. We are going to present the exercise 15, I think. And the team is made of Diego Asanza, Leonardo Gonzalez, and Victor Naum. And well, myself, Angel Ayala. First, I'm going to start by explaining the theoretical concepts. And first, we start with the Ohm's law and its formula. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperature remain constant. Mathematically, this current voltage relationship is written as V, meaning voltage equals the current times resistance. In the equation, the constant of proportionality R is resistance and has a unit of ohms with a symbol of weight. The same formula can be written in order to calculate the current and resistance respectively as it follows. Current equals to voltage divided by resistance, and resistance equals to voltage divided by current. Ohm's law only holds true if the provided temperature and the ordered physical factors remain constant. In certain components, increasing the current rises the temperature. An example of this is the filament of a light bulb, in which the temperature rises as the current is increased. In this case, Ohm's law cannot be applied. The light bulb filament violates Ohm's law. As summary, Ohm's law states that the voltage across the conductor is directly proportional to the current flowing through it, provided all physical conditions and temperature remain constant. And Ohm's law equation is voltage equals to current times resistance, where V is voltage across the conductor, I is the current flowing through the conductor, amperes, and the resistance is the resistance provided by the conductor to the flow of current. Now the definition of electrical current and its components. An electronic circuit is a structure that directs and controls electric current to perform various functions, including signal amplification, computation, and data transfer. It comprises several different components such as resistors, transistors, capacitors, inductors, and diodes. Conductive wires or tracers are used to connect the components to each other. However, a circuit is complete only if it starts and ends at the same point, forming a loop. The complexity and the number of components in an electronic circuit may change depending on its application. However, the simplest circuit consists of three elements, including a conducting path, a voltage source, and a load. The first element, conducting path. The electric current flows through the conducting path. Though copper wires are used in simple circuits, they are rapidly being replaced by conductive traces. Conductive traces are nothing but copper sheets laminated onto a non-conductive substrate. They are often used in small and complex circuits such as printed circuits boards or PCB. The voltage source. This primary function of a circuit is to allow current to pass through it safely. So the first key element is a voltage source. It is a two-terminal device such as a battery, generators, or power system that provides a potential difference voltage between 2 points and the circuit so that current can flow through it. And the load. A load is an element in the circuits that consumes power to perform a particular function. A light bulb is the simplest load. Complex circuits, however, have different loads such as resistors, capacitors, and transistors. Now to explain configuration of electrical circuits in series and in parallel. There are two basic ways in which to connect more than two circuit components, series and parallel. First, the series circuit. Here we have the three resistors labeled R1, R2, and R3, connected in a long chain from one terminal of the battery to the other. The defining characteristics of a series circuit is that there is only one path for electrons to flow. In this circuit, the electrons flow in a counterclockwise direction, from point 4 to point 3 to point 2 to point 1, and back around to point 4. Then parallel circuits. Again, we have three resistors, but this time they form more than one continuous path for electrons to flow. There is one path from point 8 to 7 to 2 to 1 and back again to 8. There is another from 8 to 7 to 6 to 3 to 2 to 1 and back again to 8. Then there is a third path from 8 to 7 to 6 to 5 to 4 to 3 to 2 and to 1 and back again to 8 again. Each individual path 8 through R1, R2, and R3 is called bridge. How voltage is measured using a voltmeter. A voltmeter is an instrument that measures the difference in electrical potential between 2 points in an electric circuit. In order for a voltmeter to measure a device's voltage, it must be connected to a parallel to that device. It is necessary because objects in parallel experience the same potential difference. An analog voltmeter moves a pointer across a scale in proportion to the circuit's voltage. A digital voltmeter provides a numerical display, and many measurements that can be converted to voltage can be displayed on a meter that is properly calibrated. Such measurements include pressure, temperature, and flow. There's an image. In order for a voltmeter to measure a device's voltage, it must be connected in parallel to the device. This is necessary because objects in parallel experience the same potential difference. Now, how the electric current in a circuit is measured using an ammeter. An ammeter measures the electric current in a circuit. The name is derived from the name for the SI unit for electric current, amperes. In order for an ammeter to measure a device current, it must be connected in series to the device. This is necessary because objects in series experience the same current. They must not be connected to a voltage source. Ammeters are designed to work under a minimal burden, which refers to the voltage drop across the ammeter, typically a small fraction of a volt. Now my teammates are going to explain the experiment.
Well, now for part 2, we have all the 3 experiments that we had to do. Start with the first one. The first one is we have to make this circuit in the simulator. So we know that this is the voltage and this is the resistor. So this is going to be the battery. So it had to be like this and 2 resistors. But for the sake of the experiment, I'm going to already have here the circuit that we have. Here you can see that, as you said, 9 volts is the battery. The resistance 1 is 33 ohms and the resistance 2 is 100 ohms. And we can see that all the current in all of them is the same because it's a continuous circuit. And so we can come back here. It's going to ask us the value of the voltage and the voltage on all the resistors. Here you can see that we put the both here. The battery has 9. Here the resistor has a negative because it's resistant, so it needs to retain voltage. And to the other one, we have 6, and that's all we have here. And now we have to measure for the currents that we already did, that we know that since this is a continuous circuit, it's going to be the same as in each point. That is going to see to be 0.07 amperes. And now with my friend Asansa.
Yeah, I'm going to explain the experiment too. And this is the circuit, a parallel circuit that is asking us to solve. So first, it says to measure the voltages in the battery and in each of the resistors, and record the measure values. I tried to measure with this, the voltmeter, and it shows that the voltage is the same for each resistance because it's a parallel circuit. And these are the data of the voltage. Next is measure the currents in each of the circuit elements and record the measure values. And these are the currents is 0.09 amperes, and next is 0.60, and the battery is 0.69. And these are the recorded values. And next, my friend Victor is going to explain the experiment 3.
Well, for the experiment 3, we had to build this the circuit, which is a mixed circuit. These are the voltages using the simulator to, well, the voltages for each resistance and the currents for each using the the simulator. Here we have it. Okay, and now the analytical check. Well, for the experiment 3, we have to build this circuit, which is actually a mixed circuit, a mix of the serial and the parallel circuit. And using the simulator, we had these values. The variable voltage is of 24 volts, and the voltage of each resistor is of 16, 8, and 8. And the current is the total current of the battery is 2 amps. And for the resistor number 1 is 2, and for number 2 and 3, 1.6 and 0.4 respectively. And here's a picture of the circuit actually built in the simulator.
Well, now for the part 3 that we have the analytical check, we've given these equations or problems that we have to solve. For the first experiment, we have to find the equivalent resistance, the current to the circuit, the voltage in each resistors, and we have to have a photograph of the calculation. Here we have the results that for the first one, 33 ohms, the current is 0.07 amperes as we saw, and the voltage in each resistor for the first one is 2.31, the second one is 7 volts. And here we have why. In the equivalent resistance, we have that is the addition of all the resistance, so 33 plus 100. For the current, we have that it's voltage over resistance. So we have the voltage here over resistance. We have the resistance and the voltage, so 9 over 123. And for the voltage, we have to multiply the current and the resistance in each resistor. So for the first one, we have 33, and for the second, we have 100. And it will be 2.31 for the first one and 7 for the second one. Now, my friend Devasans.
So I'm going to present the procedures of the parallel circuit. First, to have the equivalent resistance, I sum 1 over 10 plus 1 over 66, and that gave me 0.115 ohms. To the point B, that is the current supplied by the battery. I used the simulation to have that, and the current that circulates through each of the resistors are, first I divided 6 over 10, that gave me 0.6. Next, to have the next one, 6 over 66, and that gave me 0.0909. And the processors are not complex, so I made it in my computer. And next, the mixed circuit by Victor.
And for the mixed circuit, the overall resistance is of 12 ohms, and the overall current is of 2 amps, and the currents and voltages in each of the resistors are here. And for in the current, for 1 is 2 amps, for 2 1.6, and for 3 is 0.4 amps. And in voltages, for 1 is 16 volts, and for both 2 and 3 is of 8 volts. And now the calculations. Okay, well, being this mixed circuit, I had first to break down into two the circuit. First, calculating the parallel circuit with the formula that is seen below the red square, and there we have the values of resistance 2 and 3, and at the end I had to invert both values so I can get the resistance of both 2 and 3 being 4 ohms. And now, just by making a simple sum of the resistance 1 and the resistance of 2 and 3, we had the total resistance is of 12 ohms. And for the current can be is the result of the voltage divided by the resistance overall. Now that we had it being 12 ohms, 12 ohms divides 24 volts, and we have the current of 2 amps. And now for the serial circuit, all of the current it's the same. So in the resistance 1 is going to be 2 amps, and resistance 2 and 3 is going to be 2 as well. However, in the parallel circuit, we had to make another calculation because, well, first the voltage in a serial circuit, the voltage has to be, the total voltage is the sum of every resistor voltage. So in the resistor number 1, we had that the voltage is of 16, and the number 2 and 3 is of 8. And in a parallel circuit, the voltage is equal. So now with the voltage of resistors 2 and 3, we could get that the current, the value of the currents, which is 1.6 and 0.4. Yeah.
Entonces ya nos vamos a la clase de música. Ah, no, hay que.
Entonces, despídenos
Quita la
rápido
pantalla,
ya.
quita la pantalla compartida, quita la
A
pantalla.
ver,
Ah,
una,
nos
dos, tres.
despide.
Thank you for watching, and this was
Thank-
the exercise 12.
Thank you.